Function vocabulary, extrema, and end behavior. So extrema is an overarching word for minimums and maximums, and there's a couple different types of minimums and maximums. The first type is an absolute minimum. So an absolute minimum is the absolute lowest point on a graph, which can be an endpoint. So if part of your graph ends at an endpoint, it can be the endpoint. So you're looking for the lowest point that you can possibly have on a graph. The absolute maximum is the absolute highest point on a graph and also can be an endpoint. Now the reason that I'm saying something about the endpoint is that the relative or local minimums and maximums cannot be endpoints. So relative or local, I'll be usually calling it the local. The local minimum is a low turning point on a graph. It cannot be an endpoint, and it kind of looks like the bottom of a valley. So you're looking for like the bottom of a turning point. So it would be down there at the very bottom of a turning point. The relative or local maximum is a high turning point on a graph. Again, not an endpoint because it doesn't turn at an endpoint, it ends. And it looks like the top of a mountain. So you're looking for bottoms of valleys and tops of mountains for the local minimum and maximum. Now we say that there is no absolute minimum or no absolute maximum if the graph goes to infinity. So there's no absolute minimum if it goes to infinity in the negative direction, and there's no absolute maximum if it goes to infinity in the positive direction. And that's due to you can't find the top or the bottom depending on if it goes to infinity in that direction. So now we're going to practice this. Now when we name the local minimum or maximum, we use the coordinates so that we could easily figure out what you're referring to. So we're going to write it as coordinates. So remember that for the local, the minimum is like the valley and the maximum is the top of the mountain. And the local minimums and maximums cannot be endpoints. So if I try to find the local minimums, this right here is going to be a local minimum. It's like the bottom of the valley. So the bottom of that valley is at 1, -1. The maximums are at the tops of the hills. So this is a local max, and this is also a local max. So the local maximums are at -1, 3 and at 2, 1. So those cannot be endpoints. Now absolute minimums and maximums can be at endpoints. So if we were to look at this graph, the absolute lowest point of this graph is an endpoint. So this is the absolute minimum, and it is at 3, -2. The absolute max, the highest point, happens to also be a local max. So this right here has two purposes. The absolute highest point on that graph is at -1, 3. Okay, let's try one more that has one arrow in it. So again, local mins and maxes can't be endpoints. We're looking for valleys and mountains. So a local minimum right here, this is like the bottom of a valley. It's where it kind of turns around and starts going back uphill. So that local minimum is at -1, 0. We do not have any other valleys because remember that you cannot have an endpoint as a minimum. So that one only has one minimum. Maximums are the tops of hills. So this is going to be a local max. So that is at -2, 2. This is also a local max. So it is at 2, 1. For the absolute minimum, due to this arrow right there, you're going to write none. There is no absolute minimum because you can never find the bottom of this graph. And the absolute max is going to be, again, the same as that local max. It's not always the case. It's just the case on what I happen to draw. So that's going to be at -2, 2.